I'm going to try to keep this as short as possible. And really, if you can understand this formula, that's all you need for this section. Because we're talking about binomial experiments. And it's a binomial experiment as long as it meets the following conditions. They're n independent trials, so you do something n times. And for each trial, you can either get a success or a failure. So it's like flipping a coin. We'd say heads would be a success maybe, tails would be a failure, or flip it, tails would be a success, heads is a failure. But really there's only two outcomes, success and failure. The probability of success is the same for each trial. If the probability changes, you can't use this formula, but if, flipping a coin, you always have a 50% chance of getting heads, you can use this equation. The probability for successes is p, and the probability for failures is 1 minus p. So the formula looks like this. It says the probability, if you want to know about k number of successes, equals a combination formula with n number of trials. So maybe you flip a coin 20 times, then n would be 20. K number of successes. So like we flip a coin 20 times and we care about getting 5 successes. Then k would be 5. You multiply that times the probability for getting a success. I'm going to run out of space to write here. Probability for success to the k power, of course k is the number of successes you want again, times 1 minus p, that's the probability of failure, so just the opposite because there's only success and failure. So let's put prob of failure to the n minus k, which is number of trials minus the number of successes, or really you can think about it as the number of trials remaining where you didn't get a success. I think this problem illustrates this example pretty well. It says this player of the Sacramento Kings made 92.7% of his free throw attempts in the 2003-2004 NBA regular season. What's the probability that he'll make exactly 10 of his next 15 free throw attempts? So what we care about is we care about the probability where the number of successes is 10. We're going to set that equal to a combination with a number of trials. Number of trials is 15. He's going to take 15 shots. And we care about him getting 10 successes. So there's any number of combinations. He can make the first 10, the last 10, some combination of that. So that's why we have to put this in the beginning. We multiply that times the probability of him getting a success. And we know from his current track record that his probability of getting success is 0.927, 92.7%, but 0.927. Take that to the power of k, which is the number of successes we care about, which is 10, times the probability that he fails. The probability is just 1 minus p, so if he's successful 92.7% of the time, he will be unsuccessful 7.3% of the time. Expressed as a decimal, it's 0.073. And to the power of the amount of failures. So he's going to get 10 successes and 5 failures. This is a long equation. Of course, we can plug that into our calculator. We just have to be very careful, but we can plug it in all at once. So let's try that. And I already just did this to check it out. So it's 15 NCR 10 times 0.927 to the 10, all these things in parentheses, times 0.073 to the 5th, and that gives us 0.0029. And the third number was, we'll round it to 2. So there's a 0.00292 probability that he will make 10 of the next 15 free throws that he takes. Now, the reason why this number seems pretty low is because we're talking about how it's exactly 10. Of course, since he's pretty good at free throws, he's probably going to make more than 10. But here we only calculate for exactly 10. Of course, if we wanted to know what's the probability he'll make 10 or more, then we have to do this for 11 and 12 all the way up to 15 if it said 10 or more. Then we're going to add all those probabilities together.